Welcome back to Unit 7. This is going to be 7.7. And today we're going to be looking at our factoring trinomials. So let's go ahead and take a look at our FOIL method again, just as a refresher. We have our first, our outer, our inner, then our last. So x times x is x squared. Then we have 1x and 5x and positive 5. We add that x. Then we're going to combine our like terms, which we are left with x squared plus 6x plus 5. But what if we're given a problem that starts off like this? How do we get the equation back into um, our binomial, how do we get it back into that binomial format? Well, that's what we're going to look at today on how to reverse this work. So what you need to remember is to factor trinomial of the form, this form right here that we see. It's x squared plus bx plus c, and this is basically that term right here. So if this would be our x squared, this 6 would be our b, and then this 5 would be our c, for example. So what we're going to do is we're going to find two integers that, sorry, add to B and also multiply to C. Okay. So if this was our 6, right, and B is our 6, we need to find a number that is both being added to make 6, but those same two numbers are being multiplied to make 5. Okay. So let's take a look right here. We have a guided example, and they give us x squared plus 7x plus 12. So we're trying to find something that adds to 7, which is our b, and something that multiplies to 12, which is our c. So let's go ahead and move this up a little bit. So let's go ahead and list the factors of 12. That's what I like to start with. If I start with 12, I know that 1 times 2 is 12. I know that 2 times 6 is 12. And I know that 3 times 4 is 12. So I have three possible options that could be our numbers, our factorized numbers. And so I need to see if any of these two sets of numbers add up to 7. So 1 plus 12 is 13. Now, what's kind of cool about this is that I can actually make one of these negative, right? Let's just say I have 1 and negative 12. Well, now I have negative 11. Okay, so you have a lot of options here because you do have that ability to make some of these numbers positive or negative. If I have 2 and 6, well, 2 plus 6 is 8. Okay, what about 6 minus 2 is 4. And then, or I can do it the other way. I could do 2 minus 6 is going to be negative 4. So that option does not work for me. Even if they were both negative, I have negative 2 and negative 6 would give me negative 8. So that is not an option. But if I look at this 3 and 4, I know that 3 plus 4 is 7. So that would have to be my option. So let me go ahead and write that. I'm going to say that the answer I choose is 3 and 4. Let me bring that down here. Okay, so now I'm going to write two binomials using these integers, then we're going to distribute to check. So for example, our x is going to stay the same. So we have our x plus a number and then x plus another number. So in this case, I'm using a positive 3 and a positive 4. So let's go ahead and check and see if that works. X times x is x squared. 3 times x is 3x. X times 4 is 4x. And then 3 times 4 is 12. We're gonna go ahead and combine those like terms. I have a 7x. And then I'm going to bring everything else down. So I can see that this does in fact meet my original problem. So my answer is in fact these two binomials that are our factored um, trinomial. Okay, let's take a look at another one. Let's look at number 7. Okay, I have g squared plus g minus 6. Okay, well, I know that in front of my g, there is this understood 1 right here. And remember, I have to find a number when I multiply the two, make one. I'm sorry, when I add the two, I get a positive one. And when I multiply the two, I get a negative 6. So let me go ahead and start by writing out the possible options for negative 6. So for negative 6, I could have 1 times 6, and either of those could be negative. I have a negative 1 and a positive 6, or I can have a positive 1 times a negative 6. Those would both work. Now, another option for getting negative 6 is 2 times negative 3. I can add, if I add those two, I actually get a negative 1, but I could switch that around to say, okay, well, negative 2 times positive 3 gives me negative 6. And if I add the two, then I actually do get a positive 1. So this would actually be the two integers that I need for my problem. So let me go ahead and write that. I think it's negative 2 and positive 3. Let me go ahead and make some room and double check my work. G times G is G squared. Negative 2 times G is negative 2G. G times 3 is 3G. And then 2 times negative 2 times 3 is negative 6. I'm going to combine those like terms. I'm left with G squared plus G minus 6, and that is the original problem that I had. So this is, in fact, the correct answer. Okay, let's take a look at number 23, and this is examples with with a greater common factor, okay, with the greatest common factor. So what we need to remember about the greatest common factor is that we can take something out of this trinomial to make it simpler. Okay, so if we look at all those terms, we're going to look at first our coefficients, then our variables. So if I look at the coefficients, I have a coefficient of 4, 12, and 8. And what that tells me is that off the top of my head, I know that I can take a 4 out of a 4, a 4 out of a 12, and a 4 out of an 8. So that's what I'm going to do. I'm going to factor out my 4, and I'm going to leave everything else inside that I could not take out. So since I took a 4 out of the 4k squared, I'm going to leave my k squared. Since I took a 4 out of that, I'm going to leave a 3k, and then I take a 4 out of my 8, and I have a positive 2. Now I have a factored trinomial. Well, I have the 4 taken out of this trinomial. So now I'm going to go ahead and factor. So I'm going to look at this b, right, which is 3. I'm going to say, okay, I need something to add up to 3, but that also multiplies to 2. Well, the only two factors, a positive 2 is going to be 2 times 1, or negative 2 times negative 1. And that's the only other way I can get that positive 2. So here I'm going to say, okay, well, 2 plus 1 is in fact 3. Negative 2 plus negative 1 is negative 3. So this is not going to work. It is in fact my first option. So I'm going to rewrite this as two binomials with the variable of k. And I have a positive 2 and a positive 1, but don't forget that 4 that we factored out, because that does matter if we need to redistribute these binomials.